So in this video we're going over hydroboration, and I want to show you how to draw the correct product. And so this hydro just means that you're adding water to the double bond. So you're going to get an H and an OH on each carbon. And so what I want to do is show you the intermediate for this reaction. So the intermediate for this reaction is shown here. So you have an H, a B, and there's two other hydrogens on this boron. And the reason this is the way it is because, well, first off, hydrogen is more electronegative than boron, so it has a partial negative, and boron has a partial positive. And usually what you see in alkene reactions is that the more negative atom gets attached to the more substituted carbon, because the more substituted carbon is more stable with a positive charge because of hyperconjugation. So this carbon will be partial positive and this one will be partial negative, right? And so the result of this intermediate is that we have an H and a BH2, right? But what about stereochemistry? So our intermediate is a ring, and you see whenever you have a ring intermediate, that means that it's going to be syn addition, which means that when you have a product with stereochemistry, both of the substituents have to be on the same side. So this is actually either two wedges or two dashes. Right? And these have the exact same stability, and so that means that the ratio between them is going to be 1:1, and you'll get a 50-50 split. And so what happens next? So that's the first step. The second step is you're adding NaOH and H2O2. And I won't get into the mechanistic part of that, but what happens is you swap your BH2 for an OH. And again, this is a syn addition, so it's actually either of these two chemicals. And so when you switch that BH2 for an OH, that doesn't switch to stereochemistry. So the products of this reaction should be this molecule and this molecule with a 50-50 split. But in this case, specifically in this case, this primary carbon has two hydrogens attached to it, and so there's actually no chirality, so you can just draw it like this. So that's your product in this reaction. And the reason it's attached to the primary carbon instead of the secondary carbon is because this whole deal here, where usually we see hydrogen as a positive charge, but in this case it has a partial negative, and so you reverse the whole story, and we get our substituent on our least substituted carbon, which is an anti-Markovnikov addition. So anti-Markovnikov just means that your substituent is now on the least substituted carbon. So hopefully that cleared up some confusion, and thanks for watching.